Hey there, honors kids. We're going to take a look at some unit conversions and some scientific notation. I know that there's a struggle right now with this in class, so this video is going to address it from scratch and just go over a handful of examples. So hopefully it will help you out. So ignore the density stuff up top. We're not looking at density, but take a look at my expression here. It's a number in scientific notation. So let's remember first the absolute rules that we need in order for writing one of these. All right. The purpose of the scientific notation is to take really big or really small numbers and write them more concisely. So we're not putting a bunch of zeros when something is huge or really, really tiny. One of the things that's always true is that this number right here that you start with must be between 1 and 10. So if you're ever given a scientific notation where that's not the case, then it's written incorrectly. The way that we write it in here, all right, not all teachers teach it like this, but we use a capital E to represent the times 10, which is ultimately decimal slides, to show the number getting larger or smaller, all right? So the E right here, -7, would be the same as saying times 10 to the -7, all right? But of course, this -7 right here, which is the same as that one right there, is the decimal slides. All right. So then the question becomes, all right, well, if I have this number of 2.5, and I know that the number of decimal slides in this example is, well, it's a -7. 7 is what we care about. That's how many times we're going to slide the decimal. But of course, the negative has meaning, all right? The negative part of the exponent is an indicator that the expanded form that I'm about to write needs to be less than 1. The negative indicates less than 1. Now, there's only one direction I can slide this decimal to make the resulting number be less than 1, and it's to the left. So you can memorize to the left if you want, but I think it's easier to just connect the negative exponent with the small overall number. So if I slide it 7 times to the left, it'll go 1 to the other side of the 2 initially, and then 3, 4, 5, 6, 7. All right, there's my decimal now. All right, so each of these spots I've created would have a 0 placeholder to show the real size of the number. All right, so therefore the resulting number here would be 0.000025. All right, and you'll notice that this long purple number is a little more annoying to have to write, especially if you were doing a problem where it comes up a bunch of times. It would be way more concise to write my original blue number, which represents the exact same value. All right, so looking at one that uses a positive exponent. All right, so let's go 8.08. E5. All right, you'll notice a couple things here. First off, 8.08 is between 1 and 10. Has to be. The E means times 10, and the 5 will be decimal slides. All right. So I'll take my 8.08, and which direction do I want to slide it this time? Well, the exponent is positive. Therefore, my resulting expanded form needs to be a number bigger than 1. All right, so I can't go this way. It immediately becomes smaller than 1. So 5 slides. Here we go. 1, 2, puts it on the other side of the 8. 3, 4, 5. Those 3 empty spots will be the placeholders. All right, making the resulting number be 808,000. All right. So this one doesn't save us a whole bunch of time because that's not that much more characters than that. But again, the purple and the black values are the exact same number. Now, a lot of times you're asked to go the other direction. All right, so if we start with a number like this,
Robert, that's the worst thing about being smart.
Hey, bring it down a level, please. I don't mind y'all talking about, real chemistry stuff, but that question is just making my video uglier. Okay. Anyway, so here's a big number, right? All right. So the decimal in this case is not shown, which means right now there's only two significant figures, right? Because all of my zeros that end the number are insignificant with no decimal. But in terms of converting this expanded form, long, ugly, terrible number to scientific notation, all right, well, we know that the decimal really lives right there. But where does it have to live for proper scientific notation? Well, it has to be between 1 and 10. The only place that decimal could go to make this value become between 1 and 10 is right between the 5 and the 6. All right? Now, if it were there, where I'm saying we want it to be, it would become 5.6. All right, so hooray, now it's a number between 1 and 10. But how many times do we have to slide the decimal to get it to that point? All right, well, let's find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I know my decimal slide, so capital E for times 10 because that is what makes the decimal slide. The number of slides was 10. And you'll notice how it's positive. Of course it's positive. Look at my starting number. The starting number was above 1, therefore we want the exponent to be positive. All right, one more example quickly. All right, so if we just had this small number, all right, it's not very small, but it's certainly smaller than 1, right? So that matters. All right, hey, look, the decimal's shown this time, but I need the number to be between 1 and 10. All right, so the decimal needs to be right there. If it were where I'm pointing, it would be 2.24. 2.24 times 10 to the negative. Starting number was less than 1. And how many times do I have to slide the decimal to get it from there to there? The other item I want to address is unit conversions. All right, so go ahead and pause the video and write this down or take a picture if you don't have access to it for whatever reason. But one of the things I'm going to be referring to while I'm referring to this picture, I'm not going to keep holding it up, is the prefixes that are over here and their connection to the exponents that are over here. All right. Now, I also want to point out that as you go up this list, those prefixes are making the units larger. All right. Suddenly it's not focused. As you go down the list, the units are getting smaller. All right. Those prefixes are getting smaller. So that'll be important as I'm explaining this to you. All right. So let's do a simple conversion. All right, we'll start with something like, what if in lab we measured 75 grams of something, but for whatever reason, we want that in kilograms. All right. You'll notice that the way I think through these, it's step by step and always the same. So just latch on to the thought process. First I want to know, is the unit getting bigger or smaller? Now, if you look at grams, you'll notice it doesn't have a prefix. So if you go back to your listing here, see that blank in the middle, in between deci and hecto? All right, that's where the unit with no prefix lives. All right, ultimately 10 to the 0. All right. So with that being true, I know I'm going from nothing to the kilo. So I'm moving up the list, which means the unit's getting bigger. And write this down if it's not already in your notes. If the unit gets bigger, the number gets smaller. Vice versa. The unit gets smaller, the number gets bigger. That helps you with the direction of which to slide that decimal. So again, no prefix to kilo, the unit's getting bigger. So I need this number I'm about to finish with to be smaller than it currently is. All right, so I've got 75. So to make it smaller, I'm going to slide the decimal that way. The question becomes, well, how many times? All right, well, 10 to the 0 represents the no prefix. The kilo, if you look at your slide there, has positive 3. So the question is, how many slides does it take to get from 3 to 0? Or just how many spots are there between positive 3 and 0? Of course, the answer's 3. So I'm going to slide the decimal to the left 3 times. 1, 2, 3. All right. The resulting number with that 0 placeholder becomes this. You'll notice my sig figs are the same, 3 sig figs here, 3 sig figs here. And now we have kilograms. All right, let's do one more. All right, what if instead I gave us 0.0012 gigagrams, all right, or let's go gigaliters. All right, you can find giga, and liters is just a different base unit. And what if we were going to convert the gigaliters down to, let's go deciliters. All right, you can find deciliters there. So again, look at the units. First question is always the same. Is the unit getting bigger or smaller? Giga is here, deci is here. So the unit's getting smaller, so the number must get bigger. All right, so I'm going to take my 0.0012. I want it to get bigger. The only way it gets bigger is if the decimal goes that way. All right, so I know that that's going to happen. How many times? Well, now this time there's prefixes for both of them. So it's just, I mean, it's a kind of like, it's integer math. All right, but if you look at the exponent for giga, all right, it's sitting there at positive 9. All right, you can go look, it's right here. Said I wouldn't do it, but I guess I'll hold it back up. Do you see how giga's positive 9 and deci's negative 1? How many integer steps are there between 9 and negative 1? Or just subtract. What's 9 minus negative 1? You'll get the same answer, of course. It's 10. It's 10 decimal slides this time. All right, so here we go. 10 decimal slides to make it bigger, right? Because the unit got smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, looks like it's going to form 1, 2, 3, 4, 5, 6 zeros right there. Making the final answer.
Yeah.
Right? Oh, stupid. We moved the decimal over there. All right, that is the decimal slid over to this position, right? We don't want to show the decimal because that would add sig figs. All right, but there's your answer. All right, the unit got smaller. The small number got a lot larger. All right, now it's sitting at 12 million deciliters. in that many gigaliters.